Hello everyone, I'm Chikako Kurokawa from Azure Air Survey. I'm a data modeler, and today I will introduce data standardization of IUL. Before getting down to the main topic, let me introduce my company and myself. Azure Air Survey is a geospatial consulting company that offers a wholly integrated geospatial service, from geospatial data acquisition to its visualization and utilization. We have various kinds of sensors, and we can survey everywhere from outdoors to indoors. I'm a data modeler to give semantics to geospatial data, and I'm also an expert of standards for geospatial information. Let's move to the topic of data standardization of IUL. In the early stage of IUL development, we chose KML as a data format. KML is an XML-based format focused on geographic visualization, including annotation of maps and images, and it is an OGC standard. KML is easy to use on Google Earth for free, and this opened the door to urban structure visualization for the municipality staff who had not been familiar with geospatial data and GIS. Once they interested in the spatial data visualization, they began to practice on it more. Now they are interested in the data with semantics for further analysis and visualization. And then we introduced STGML. STGML is also an OGC standard, and it defines classes and properties for ST objects. In addition, STGML differentiates levels of detail, LOD, where objects become more detailed with increasing LOD regarding both their geometric and semantic differentiation. And moreover, we developed IUL as a STGML ADE for urban planning to define specific objects and properties for urban planning. IUL 1.2 was submitted to OGC as a discussion paper. The latest version of IUL is 1.4, which extends a new module called Public Transit Network. The basic survey of city planning is conducted by municipalities in Japan every 5 years since 1970s. The survey results include 2D maps and statistical tables. However, the most of them are printed on my paper. Some of them are digitized, but their data formats are different. These issues have prevented the use of accumulated data. Therefore, there has been a growing demand for reusable data that can be easily analyzed and visualized. So, we set out to standardize the data format. In conceptual modeling, all items in the survey are divided into two components, which are items already defined in STGML and items not defined in STGML. Items not defined in STGML are categorized into 4 subcomponents: detailed information about city, constraints and conditions for urban planning, statistical grid data, and global model. Grid statistics is often applied on a national or worldwide level. However, the LOD defined in STGML do not cover such a rough description. So, we extend LODs for describing a global model. This figure shows the structure of LODs with a global model of LOD-1 and -2. In urban planning, characteristics of features such as buildings are aggregated into statistical units for global representation and analysis. And an administrative boundary is often used as a statistical unit. However, it is insufficient when the sizes are different and when they change their boundary. To facilitate time series comparison and comparison between cities, grid statistics, which divides the whole area into a small grid, is applied on regional, national, or worldwide level. Therefore, new concept for global model is introduced to define IUR. The global model enables using 3D city models in policy making phases and allows us to store and share all information necessary in the policy cycle in 3D city models. We developed a conceptual schema using UML. All objects defined in this model extend existing STGML objects without inconsistency according to the ADA development procedure explained in the STGML specification. This is the framework of IUR 1.4. As well as STGML, modularization is applied to IUR data model. Each module covers a specific semantic field of virtual 3D city models for urban planning. As an encoding format, GML schema is exported from the conceptual schema. If you are interested in IUR data model, please visit the website. All technical materials are available from the website. The good point of applying ADE mechanism of STGML is that it allows us to extend the data model easily without inconsistency. As an example, IUR 1.4 defines a new module for public transit network information. Transportation has a great influence on the scope and content of urban planning. And the public transit network that connects cities is indispensable information for reviewing the role of cities in urban planning and regional planning. ADE mechanism enables us to review the data model at the right time. The IUR can standardize various city information regarding urban planning. Standardized datasets enable users to do quantitative analysis such as time series comparison and regional comparison, and to visualize it in a way that is easy to understand. The current IUR is developed based on the STGML 2.0. However, STGML 3.0 will soon be published. In STGML 3.0, the new modules Dynamizer, Versioning, Point Cloud, and Construction were introduced. The Dynamizer module can link specific city object properties with specific time series data from sensor services. So, city models can be linked to the Internet of Things. The versioning module allows users to identify and organize multiple states of a city model. The Point Cloud module links city objects with point clouds, and users can get more detailed data of the future according to their scope. The Construct module allows users to describe not only urban areas, but also entire cities. Here shows the development of the IUR so far and its future. IUR is a combination of STGML and urban planning ADE. In the future work, we'll extend ADE to reflect additional needs. And to make it more descriptive, we should consider harmonization with the STGML 3.0. The IUR includes various information which is necessary for urban planning. And as an ADE of STGML, it ensures flexible and solid extension of the data model. We believe that IUL is not only contribute to urban planning in Japan, but also in cities around the world.